Hello, Professor. My name is Rui Hu, and the subject of my case study is three-dimensional digital power station system. And this presentation includes following four parts. The first part is the introduction. In this part, it makes a brief summary of my subject. The three-dimensional digital power plant system uses three-dimensional digital modeling technology to build a three-dimensional digital system for power stations. It integrates the information system of the design, construction, and operation of the power station. It integrates the management information system related to the production and the operation of the enterprise and the various related functions in the production real-time monitoring system to realize the combination of the three-dimensional model and the enterprise information system. And the second part is the background. This part shows how these concepts come from. The solar and wind energy are also difficult to integrate due to geographical differences in new energy-rich regions. The new energy power generation is dispersed and the power generation is not balanced. In order to balance the supply and the demand of the power grid and ensure the stability of power supply, the direction of power transmission needs to be developed from one direction to multiple directions. With the rapid development of information technology, three-dimensional digital technology has begun to be applied in all aspects of the power industry. The combination of virtual reality technology, artificial intelligence technology, physical simulation technology, data mining technology, and information communication technology has expanded the application prospects of three-dimensional graphics technology in the power industry. And the next part is the concept development stage. It's also one of the most important part in my subject. In this part, I will divide it into three parts: need analysis, concept exploration, and concept definition. The first one is needs analysis. It shows why we need this new system. If the power grid wants to go to the future, it needs both a power instruction and a fixed-for operation. In the power value chain for transmission and distribution, intelligent digital monitoring, communication, and control systems are needed everywhere to ensure reliable operation of the power grid. Simply put, the three-dimensional digital power station makes the equipment more simple, more efficient, more reliable, easier to operate and manage, reduces the construction and maintenance cost of the substation, and makes the grid more secure, efficient, reliable, and predictable. It shows a lot of advantages. And the next part is the concept exploration. In this part, we should consider system materialization and requirements. So how to make it reliable. I promise four basic modules. The first one is the three-dimensional model simulation of important equipment. Realize the simulation and disassembly and three-dimensional display of the main production equipment, and view the related information of each component of the equipment, including the design drawings, parts, and materials information and supplier information. The three-dimensional digital construction of the main production equipment is realized through the three-dimensional modeling software, and the actual simulation of the operation process, such as the structure operation process, equipment maintenance and the assembly of main production equipment are carried out. Combine the operating produce with a three-dimensional model to develop a dynamic and dynamic operating producer. On the basis of the virtual simulation, the equipment installation training for maintenance personnel is realized. Equipment operation training, power station operation, so and so on. The simulation assembly in the virtual environment is implemented according to the actual assembly sequence of the device. Combining the operating produce with a three-dimensional model to develop a dynamic and dynamic operating procedure, training, teaching, presentation for some personnel. And the second model is the 3D display and removing of power station panorama. This model using three-dimensional modeling technology combined with the photo material collected in the field, digitally modeling all buildings and the equipment of a power station. Using the virtual reality simulation interactive platform to make the power station panoramic view, underground and underground building facilities, main equipment and equipment working mode, operating environments, the natural environment and other related displayed. The third model is emergency plan drill. This part simulates the process of disaster occurrence and the developments in the three-dimensional power plant, and the various reactions that the operating personnel may make in the disaster environment by simulating disaster simulation and possible simulation of emergency personnel behavior. And on the three-dimensional science platform, under the conditions of minimizing the actual disaster, conduct emergency drills for disaster prevention and relief. On this basis, they will formulate various disaster emergency plans for power stations. The three-dimensional science and emergency plan simulation exercise system can be used to train decision-making and commanders at all levels, accident handlers, and emergency response behaviors. Through three-dimensional science simulation, the operability and practicability of emergency plans can be tested and evaluated, and the personnel at all levels can be improved. Emergency response capability. The three-dimensional digital power station emergency drill system uses information virtual reality means to strengthen the coordination and emergency response capabilities of the enterprise, making the emergency drive more scientific, intelligent, and virtualized. The last module is integration with other information systems. This part illustrates that rural dynamic association with power station. With ERP, it's the enterprise resources planning system. With enterprise asset management system. With parts material management system and other electrical document file management system. In 3D sense, real-time virtual view of power plant until access related information, data, and the interaction and display. Then the next part is the concept definition. This part defines some function of this term. It also defines the technology which will use in this system. As for the function, the three-dimensional digital power station system can realize three-dimensional image reproduction of all infrastructure, plant buildings, and mechanic equipment inside the power station. The construction progress of the power station construction period, the integrated management of maintenance information, equipment files and spare parts after commission, equipment training, maintenance and disassembly, personal training, maintenance plan planning, emergency play simulation, and so on, can be all realized in the three-dimensional digital power station system to achieve. And this part is define some technologies. The first technology is the three-dimensional interactive simulation platform. The VRP, it means three-dimensional simulation platform is widely used in the three-dimensional virtual simulation of various industries, such as interior design, monument restoration, industrial simulation, urban planning, and military simulation. This platform adopts a visual interface. And the complex three-dimensional sense control function can be realized by a simple configuration scripts, which reduce the technical difficulty in the development of the three-dimensional sense. And the power station technique can carry out the three-dimensional sense design and development through simple chain. The the VRP virtual platform has five characteristics. They are efficient, fast, and easy. The first one is efficient, fast, and easy to use. The second one is efficient rendering engine. The third one is the real-time high-quality image quality. The fourth one is it has a good hardware compatibility. The last one is it has good interaction characteristics. And second technology is the real-time scalable vector graphics. It means that the SVG, the scalable vector graphics, is an important component of real-time monitoring of three-dimensional digital power stations. Based on XML encoded open graphics and image standards, real-time display of power plants production configuration is realized through dynamic data interaction between graphics and real-time monitoring database. And it also has some characteristics. The first one is the SVG map can be scaled without loss, adapt to different screen resolution of various smart mobile terminals. It will not be distorted by graphics amplification, and the file size is smaller, suitable for publishing on the mobile internet. The second is SVG as a recommendation standard. iOS, Android, WP, and other mainstream intelligent mobile technology operating systems and processors all support SVG natively. The third one is the SVG conforms to be the common graphics exchange standard for the power station system. The SVG graphics used in the power station real-time monitoring system can be derived from the existing data acquiring and monitoring system of the power station without rerunning. Improve system versatility and adaptability. The real-time interaction display of the configuration map can be realized by configuring the data source and the graphical interface control. These are the two technologies of this system. And the last part is challenges. This concept is also facing some difficulties and challenges which need we to overcome it. The first is the technology of data sharing is still not perfect. And the next is it's necessary for us to strengthen the risk management and the control capabilities of the digital platform. And the last one is the making significances of big data to power companies and the coping strategies of power companies in the area of big data need to be further studied. So it shows also the three-dimensional digital power station has a lot of advantages, but this we should also overcome these challenges. in the future, I think it will come true. That's that's all. Thank you.